So for lesson 8, we're actually talking about combinations and permutations. Now, the question that you're going to do is you're going to actually answer whether you can identify whether questions are either combinations or permutations. And then you're going to apply the appropriate strategy. So the biggest question is, does the order matter? In every single case, you're going to be asking that. And we're going to identify it and do our work for today. So now let's begin. When we talk about permutations, you have to understand that order matters. So an example of that would be a photo lineup. Okay, of all the friends in your class. So when we talk about combinations, we have to understand that order doesn't necessarily matter. So an example of this would be when we picked groups, like what was it? The plumber problem. Okay. Or if you have 20 balls and three of them are, and you're just picking 3 of the balls, but you can't identify what ball is which. So for the first problem, we take a look at this. It says, an example, determine how many ways you can choose 3 bikes from a group of 7. So when you hear the word group of 7 and choosing them, we are using n is equal to 7 and r is equal to 3. And we just got to identify whether we're using permutations or combinations. Because we haven't identified that all the bikes are unique, this is a group, right? So we're going to use our combinations. So we're going to get C of 7 and 3. Punch that into your calculator and you get 35. Therefore, there are 35 possibilities. Now, remember what I told you. The reason why it's a combination is because this is a group and we haven't identified unique members in the group. Good? Moving on. Let's take a look at this next problem. This is about good old Joe. Good old Joe and his friends are practicing for a relay race, okay? Now, if there are 6 people in the team, determine how many ways the lineup can be determined for 4 people, and explain why you think it's a permutation. Here's the reason why it's a permutation. It's because order matters, right? Order matters in this case. So this one, order matters in this case, because you want to find the fastest people, right, on your team. Sometimes you may want the most reliable. It doesn't matter, right? But because of that, that means this is a permutation. So now n is 6 because there are a total of 6 people and we need 4 of them. So r is 4. So now let's do the calculation. Okay. So we're going to have P of 6 and 4. Punch that in your calculator and you're going to get 360. Now, some of you guys have this and you're having difficulty with it. If you're having difficulty with it, go and use the scientific calculator for Desmos. It's perfect for this situation. So therefore, there are 360 different teams. Or different ways we can make a team. We can make a team. All right, so now let's go and take a look at this next problem. How many ways can you sit 3 people at a table when you have 5 to choose from? When order matters. If order matters, you're literally thinking like this. All right, this box, and this box, which is basically 5 choices, 4 choices, and 3 choices, which is the same as our favorite thing, P of 5, pick 3. Okay. And if order matters, the answer is equal to 60 ways. Now, suppose that order doesn't matter, right? You don't care who sits where. We don't care where they sit. We just pick in 3 people. So in that case, we've got C of 5 and 3, which is equal to 10, which really means that there are 10 ways. So now my question is, how are these things related? So if I was taking a look at these things, you could see that if I looked at the original value for what C of 5, 3 is, so let's put in a little aside here. Okay, so when we took a look at the first permutation, it was 5 divided by 3 factorial. Okay, so that is what the permutation is. But when you actually do the combination based on the combination, we've got the combination of 5 and 3, which is going to be 5 factorial over, well, it's still 3 factorial, but then we also have to divide out the other arrangements. Okay, so that's what's actually happening here. When order doesn't matter, you divide out all the other guys because you don't care about who they are or where they sit. That's what's happening. So you can think of a combination as a permutation where you don't care what happens to any group that's in that set. So in this case, I have 3 people that I care about, but then I also don't care about those 2 others that I'm not using. That is what happens when we are using combinations. So if you ever have some difficulty punching that combination into your calculator, you can always use 5 factorial divided by 3 factorial, 2 factorial. And you just got to remember that when you're at the bottom of that fraction, those 2 numbers that are on the bottom must total to the number on top before the factorial. Okay. All right, let's move on to this next example, and we'll focus on that for our last topic of the day. So here's an example. We have this list, this set of letters, A, B, C, D, E, F, G, right? I need you to determine how many permutations of 3 letters exist, right? So if we were doing permutations and you want to do it like brute force, you literally have to look at what the cardinality is. Remember cardinality? Count the number of elements. There are 7, right? So 7, then 6, then 5 possible choices, which is the same as you could have said P of 7 and pick 3. So 7, pick 3, going from top to bottom, 7 through 3, and that gives us 210. Therefore, there are 210 ways. Now, just as an aside, when we're talking about permutations of letters, we're talking about all of the unique words that are formed by those 3 letters. They're not necessarily really words, but the order does matter in that case. And that's why we're doing permutations. Now, when we're looking for combinations of 3 letters, right? We're actually asking you for the third one, we're asking you how many 3-letter groups do we have? Now, that tells us that the order of the list doesn't matter. So basically, we do exactly what we did before. There are 7 possibilities, so we're using combinations this time. We're choosing 3 of them, and that's going to be 35. So what you would say is, you would say there are 35 groups of letters otherwise known as combinations formed. Now your work is online and the review for the course is posted as well. So once you're done this, you can start working on your review.